Hey everyone, welcome back to J into X Concepts. So in this video we are going to discuss what is meant by quantum states and measurement, the nature of observation. So if you haven't watched my previous video, that is classical versus quantum mechanics, a theoretical comparison, I'll be tagging the video link above. You can watch it there. So before starting the topic, if you are new to this channel, don't forget to subscribe and hit the like button. So without any late, let's get into our topic. Quantum states and measurement, a nature of observation. So before directly getting into what is meant by nature of observation, we should be knowing what is meant by quantum states and what is meant by quantum measurements. So let's start with quantum states. A quantum state is nothing but a representation of the complete information about a system and is typically by a mathematical function, that is a wave function. So even in our previous video, classical versus quantum mechanics, a theoretical comparison, we have said that quantum systems or quantum mechanics like qubits, these particular systems use wave function to indicate the probability of all possible outcomes. This wave function encodes the probabilities of finding the system in various combinations or configurations. So in simple, you can write the wave function gives the probability of all possible outcomes of a qubit or a wave or a quantum system. We know that quantum systems can exist in a superposition of multiple states simultaneously, so that a qubit state can be written as in this way. This is the formula for a qubit state that exists in a superposition. So that is mean by a quantum state. And now quantum measurements. What is mean by quantum measurement? A measurement is something with that we extract information from a quantum system. But unlike classical mechanics, where measuring just reveals a pre-existing property, but in quantum mechanics, measurement changes the entire system. Measurement is described by an operator acting on the quantum state. So it is an important point. So in classical mechanics, measurement or the activity of measurement or observation just reveals a pre-existing property. That's it. But coming to quantum mechanics, the measurement or the act of observation changes the system. That is, it changes the qubit. So as we have discussed in the early videos of QTA, I have said that whenever a qubit is measured or observed in its superposition state, it collapses. The act of observation or measurement itself collapses the qubit into either state, that is 0 or 1. So until the qubit is unmeasured, unobserved, it exists in a superposition of both states. So that is mean by quantum measurement. And that's how measurement affects a quantum system, and it affects in the contrast way in classical mechanics. Observing or measuring a quantum system collapses the wave function to a single definite state. Yes, it is an important point, and just now I have said this in a different way. Observing or measuring a quantum system just collapses the wave function to a single definite state. This collapse is instantaneous and unpredictable. This phenomena reveals the fact that measurement can define the outcome itself. Yes, in classical mechanics, the measurement just reveals a pre-existing value. That's it. But coming to quantum mechanics, the measurement itself defines the outcome and it changes the system entirely. The observer plays an essential role in the shaping of physical outcome. The nature of observation would be probabilistic outcomes, because we cannot predict exact results, only probabilities. Collapse of wave function. Before measurement, the system is in superposition and measurement forces it into a definite state. Observer effect. The act of measurement isn't positive. Instead, it can alter the system and the outcome. No hidden variables. Experiments suggest that the randomness is intrinsic, not due to hidden deterministic mechanism. This shift from deterministic to a probabilistic and observer dependent framework is what makes one of the most fundamental departures of quantum mechanics from classical mechanics. So it is a theoretical concept. You need to just understand the basic definitions and basic properties. That's it. And do remember these side headings like probabilistic outcomes, collapse of wave function, observer effect, no hidden variables. All these just define the act of measurement after effects in quantum mechanics or quantum systems, or in the case of qubits. That's it. So it's a small topic, and do remember, keep note of these two definitions, quantum systems and quantum measurements. They are important for 2 marks. It can be easily asked in your semester exams. So that's it for this video. I hope you have understood this concept, quantum states and measurements, the nature of observation. So do like this video and don't forget to hit the subscribe button. Let's meet in our next video. Until then, keep learning.